Welcome to Insight Builder channel, large language model automators, agent enthusiasts, and my dear friends. Can you tell me about LLM agents? It's about time we disassemble the Langchain agents and tools and see what's there inside. And you'll find it's made of prompts. Let's for a moment think about the first time that you came across the agents. Let's go into the code right now. And this particular code that you're looking, the notebook that you're looking here will be shared with you guys in the GitHub repo, and the link will be shared in the description below. I'm going to try and analyze a task_analyze3.json file that is present inside the repo. That file also will be shared with you guys. And just a minute, let me open the task. Yeah, so this is the file that I'm going to work on this case. So let's close this and let's begin. So I'm going to execute this. I am going to bring in a couple of functions as well as classes in order to parse this JSON file. So for that, the JSON toolkit and the JSON spec, these two I need to import from the respective tools and agent toolkits. So that's what I've done here. Most important idea that I want to share here is that try to type out all the commands, in fact the import statements also, to understand from where a particular class or a function gets imported from. That will give you a overview of how the entire library is structured. Let's move forward. In case of Langchain, one more point I wanted to highlight is that ensure you install Langchain and its dependencies in a separate virtual environment. Do not mix the virtual environment of Langchain with any other virtual environments or the applications that you're working on. So for an example, if you are having a Django related application and you are working on that project, do not mix that virtual environment with this Langchain agent related tutorials, because it's going to create some kind of clashes in various other libraries and modules. So avoid that on all cost. Create a separate virtual environment. In my case, I've created only LC. So I had created a virtual environment here, you can see that, and I'm using that only. Ensure that you do that. And once you have created the virtual environment, you need to install these libraries. The libraries that I've listed here will be shared with you guys also. All these libraries has to be installed in a separate virtual environment so that you can easily get the things up and running. Once you have the things installed, you need to also import the env.env file that contains your OpenAI API key. You will be needing only that API key, and also if you are working with Tavily, that I will introduce in a couple of minutes. That API key also should be present in this env file. Here I am opening the JSON file and I am trying to load the JSON spec and the JSON toolkit, and then you can look at the file is being read by the JSON toolkit. Important point is this: I am creating a JSON agent by using the LLM, the toolkit that I have created here, and then I am saying verbose equal to true. And once I do that, and if I run how many tasks are present in the data, you'll see that the agent is throwing an error because it is saying there is no run. Just a second, let me execute the cell again, because I suppose that the same agent I have created at the bottom and it is creating a confusion. So here you see that it is entering into the agent executor chain and it is calling this spec list keys, and from there it extracts the various keys inside my JSON file. I showed you the file a couple of seconds back, and then it is looking at my various tasks, and it finally says that there are 19 tasks present, and it reads through all the tasks also. Important point I wanted to highlight is that the way the agent is able to understand the English, next its ability to connect with the JSON file and read through the data. And third is to count the number of occurrences and provide the answer. We might actually find this answer is wrong. The point here still stays the same, that it is able to go through this process of looking at the action, looking at the action input and trying to get the final answer. So this process, whatever you are seeing in green, the action input continues until the final answer comes into the picture. So this process of actually internally the agent is coded in such a way that every time the action is triggered, the action input is searched and then the observation is sorted. So all these things are done in Python inside Langchain. It's not done with the prompt. That's something that I wanted to highlight. The second thing that I wanted to highlight is that the large language model is making the decision on the observation. This is coming from the large language model, and this is also coming from the large language model. That's why you need to understand what's going on between the inputs and the outputs, right? Most important point is that if it actually comes to this conclusion that I know the final answer, then it's going to provide the final answer. So all these decisions are already coded into the Python files or Python modules, and it is given the large language model support to provide the answer. So that's how the agent works. But how do I know all these things? Very simple. You can actually, in fact, start following the agent and you will be able to understand where it is coming from. So just give me a second. So in case of the create JSON agent, it's a part of a folder in which the agents are created. So you need to go to agents here and you need to press F12 in case of VS Code. And in case of PyCharm, I think it's still F12. So if you scroll down here in this particular file, it's a init.py. You need to go into agents, and there if you open this, you will see there are lots of agents available. And the agent that we are actually working with agent toolkits, right? So you need to go into agent toolkit and then you have to go into JSON. And that's where you will see the prompt and the base.py. So you can go into the base.py as of now, and you'll see that create JSON agent is the name that is given. And you can go back and you can look at the prompt, and it says that it's importing the JSON prefix and JSON suffix prompts. And again, if you go into that, you can actually look at the base.py. Excuse me, sorry about that. Toolkit, and finally we have the init. So this entire toolkit is having the necessary information on how to load the JSON file. And so in order to find out what is the prompt that this JSON toolkit is following, you have to just click on the prompt and it will actually take you to the JSON prefix and JSON suffix prompt. So you can see that here you will see the JSON prefix prompt. So here it says that what kind of interaction is required and what kind of errors, what kind of operations, everything it needs to do has been prompted and updated here. And in case of JSON suffix, it's just begin. Also, you can see this string literal kind of a setup where the question is given as the input and the agent scratchpad. This is actually given as a separate variable that can get updated step by step. So the thought that it's coming in case of, just a second, let me go back. The thoughts that is coming here when you run this thoughts. So all these thoughts are written into the agent scratch pad that you saw just a second ago, and it keeps on updating. So that's how the agent keeps track, and also this thought is actually entering back into the prompt. So let me go back. It's actually entering back into the prompt, and from there it is trying to provide the updates. So just a second, sorry about this. So it's entering here again, it's getting updated here. It's not visible here, but in when the Python code is executed, this area will get filled with the thoughts. So step by step, you will see instead of one thought, there will be all the thoughts that we are seeing here. So it will be part of the prompt itself. So that's how the agent is able to take the decisions by looking at the entire prompt. It's not only looking at a single static prompt. That's one way of looking at the agent, right? We saw the create JSON agent. The another way to create agents is to I have given some notes about agents here, but just to take a digression here, the agent is actually a chain. It's similar to a LLM chain, which starts with a prompt, has a LLM in the middle, and then there is output parser. This output parser, if it contains a function, and then it becomes a function calling output. So it can call the function using a different kind of object in Langchain. So even the function calling is not done by the large language model, it is done by the Langchain primitives. This is also one point I wanted you guys to remember, that large language models by themselves don't call the functions. Yes, OpenAI have function calling APIs. The same way the APIs will need some kind of inputs. That inputs is what the Langchain will prepare and give it to the OpenAI. After that, the OpenAI API will call it. But preparation of that input is still done by the Langchain team, Langchain classes and objects. So I am not diving into that level of detail in this discussion, but I want you guys to understand that large language model only creates the prompts. That is, the Langchain backend creates the prompts in the name of agents, and then it is feeding into the large language models for getting the output. The other way is to create agent executors. In order to create the agent executors, we need to work with a different kind of objects and functions. So here you see that we are going to work with Tavily search results, and also we are going to work with Langchain agents. So Tavily is one of the search reply providers, which can be made into tools, and it can be provided to the agents. In this case, the tool has to use something called as a run method to get the output. So you are seeing the output here. Let me execute this just to avoid any surprises. And because there is actually a JSON agent at the top, so that might actually create a challenge. Now this is the tool. In case of agents, we need to give the tool to the agent. And in case of the agent that you are going to pull, we are going to use React Chat JSON agent. And it is very similar to the create JSON agent that we saw above, but in a different format. So this HWChase17 React Chat JSON is coming from this particular link. You can go to this link and you will be able to find it out. You will be able to read out the entire prompt. You can also look at the prompt at the bottom also. So this prompt, the React Chat JSON, is called as an agent, but it's actually a prompt. If you execute this, you will see the prompt templates, the metadata, the input variables, etc. You can see all of these things here. And you can see the entire prompt also here. But this is just the part of the agent. So next what you are going to do is, this is where the actual agent gets create JSON chat agent. Here we are going to provide the LLM. We are going to provide the tools, that is a Tavily agent that we created in the list, and the JSON prompt that you saw here. All these things we create, but once you create it, you will see that this output comes in. So let me actually hide this, clear the cell outputs. Now let me create this again. So once you create it, this print statement happens. This is happening to show you the tools that are getting used, and the name of the tools are also getting updated. So you see the tools, we get the Tavily search result JSON, and it provides the description of that particular tool, and it also tells the name of the tool, right? Following that, you see the system message, which contains the prompt. So if you look at the template of the system message prompt, you'll see it's very, very big. So there are lots of information in this. I'll be showing you next how to access this prompt inside Langchain by using a very simple rule. So, and after this system prompt, we have the action input. So this is where the action input, this is where the call to the functions, if it is there, will get, if the tools are there, will get initiated. And again, we have the human, we have the message placeholder also to end with, where all the information related to the output or observation is placed into the scratchpad. So, but where is this prompt coming from? For that, we are going to follow the rabbit hole. So let us go to create JSON agent, and once you go to create chat JSON agent, you will see, okay, what I did was I clicked on this particular import, pressed F12, and that brought me to this base.py file where you see the create JSON agent function. In this create chat JSON agent, you'll see the familiar things that we updated right now. And as you scroll down, you'll see that this is the prompt. This is the complete prompt that we saw a second back. And here is the system prompt that will get updated. So in the system prompt, if you scroll down, you will see that we are updating the tools also, and we are also updating the response format. So the agent is running based on the prompts. It's all the agents that you see in the backend. I'm just giving you an example here. I'm just showing you 2 examples, but all the agents that is created inside Langchain or in any of the other areas, other agents that you see in the wild as of now, as of today, things can change tomorrow. But as of today, it's just the prompts, and based on the prompts output, the logic written on top of the output using Python or any of the programming languages help to create an illusion of decision by the agent. It's an illusion. The illusion that is created purely through the processing of the text. So let's go back. It might actually, sound very demoralizing, because AI still has a lot of challenges to solve, and as of now we are actually using these kinds of ways to input the tools and use the output and call the, so if we actually get the chat template like this, we actually get the message placeholders, and then we can all these things that you saw outside has been created manually, meaning manually in the sense programmatically using Python, and then it has been updated. So here you can see the prompt gets updated using the tool renderer. There is a separate function that uses tool renderer, and then it actually joins all these tools and then creates the prompts. And you can see the prompt partial variables and prompt messages. So these things are updated back to the large language model, and if there is any requirement to call the functions or the tools, then there is something called as function messages. So the function messages gets called, and from there you can see that here there is something called as log messages, and also in the same way there is function messages also. Here if you take a look at the template tool response, if you follow that, you will see this is again a tool response, is again a output prompt. So you can see the observation that you are seeing here is coming from the tool, and this is how the update is given, and again it is a prompt. You saw that, right? And this prompt is converted in such a way that it will be in the JSON format. If you scroll down here, you can see that do not respond with anything except a JSON snippet. But if you go to some other, if you go back and if you take for an example a regular this is JSON chat, if you take some other example, so let us take React, and if you look at their prompt, so that will be completely different. So all these have separate prompts, separate parsers, and also their own agents and their own prompts. So if you want to look into React, so before that let us complete this. This is how the agent is created, but agent is only part of it. We have to actually have an agent executor. As you saw, there are tools getting created, tools getting included into the agent, but how will you trigger the tool? I am telling that there will be internal prompts that will get updated based on the tool names, but how will they call the tools that is outside? The tool is outside here, correct? If you go back, the tool is here. It is a Python object, Python variable. So how it is going to call this tools list, and it is going to take this particular tool and it's going to execute this particular method? How is that going to be done? For that, you need the agent executor. And in order to do all these things, internally Python has supporting objects and functions that do it. It's not done by the large language model. Again, with the large language model, the prompt templates and the output parsers all work together to give you an illusion of the agents doing all the work. But in the backend, there's a lot of logic involved. So I'm going to create the agent executor right now, and I'm going to call this AgentExecutor.invoke. The moment I invoke, so I am asking when was the son born, and I'm going to execute that, and it is entering into the executor chain. It's calling the Tavily search result, it is getting the output, and the AI is responding with the response. And you see that son is primarily composed of so and so, and it's giving me a long answer, but it's still not providing me any answer here. In this case, there is no answer that I got. Okay, but in the last time when I executed this, it actually got the search result from some other source, and it was able to answer me that it was 4.6 billion. So that itself shows you that these agents are still have a long way to become perfected. Even after 1 year of 1.5 years of work, there are lots of things that you can perfect. Now, where are the prompts? Where is the exact prompt that gets updated for the agent executor? So for that, you can actually follow a couple of ways. So you can follow agent executor, you can follow invoke. Okay, both are different. So I will show that to you. So if I actually follow agent executor by clicking F12, the agent executor is actually a chain. Agent is basically a chain that, as I already explained, will have a prompt, will have a LLM in the middle, and will have an output parser. And this chain will have, this is how the agent is getting created. The agent executor is getting created, sorry about that. And the agent executor will have various methods and supporting functions to execute stuff. I'm not going to go through this step by step. The idea that I wanted to show you is that this agent executor will not have invoke. So if you go back here and if you search for invoke, this is where the things become really confusing. So if I search for invoke here in the agent executor, excuse me, let me go back. Let me click on this, do an F12. And if I search in this file, agent executor class definition, and if I search for invoke method, you will not be able to find the invoke method, right? You will not be able to find that. The reason is that the invoke method comes from a different chain. You can actually see, excuse me, you can actually see that there is a invoke, but invoke will not be there. Let's go back. So now let us click here and let me again do the F12. Now you will see that it is going to a different file altogether. Earlier it was in agent, right? But now it is under chain. And if you scroll up, you will see that it is under the chain abstract base class. Okay, this is actually a blueprint class. It's not actually a class that we want to get the information from. So even using the internal Python, VS Code's internal way of tracking the files, it's difficult to know where this particular invoke comes from. The point I wanted to make here is that sometimes you can use these kinds of supporting tools to locate where the prompt or where the logic is coming from, but other times this may not work. Okay, the idea is that the more you start trying out these agents and trying to understand the backend details, then you will actually get more information. It comes with practice. Most of the time you have to dive a little deeper. So as we saw here, the first question, we started with this. The first question that raised in your mind when you saw that agent execution starting, it has to continue to a level where you can clearly understand that the agent, the action that you are seeing by the agent is done and powered by the prompts. Now think about the questions that you have got in the past. So you would have asked this question: how it is able to understand English? What happens inside the agent executor? How the agent calls the tools? All these questions can be answered if you actually believe. First of all, you need to understand that okay, the only prompts are actually doing all the work, along with the support of Python functions, classes, methods. So this idea should be present. Then you will be able to search for answers. based on for these kind of questions. And yeah, are agents really just prompts in the backend? In fact, yes. So there is an entire repository where people update the prompts, and it's called as Langsmith, as I already showed you. This particular area, this particular link, if you follow this, you will go to that particular smith.langsmith.com, where you can get all the prompts that has been updated by many people, not just Howard Chase. Other people also updated. You can just click on that and you can see the prompts there in live. Also, you can try it out. You can understand the tools, the tool names, how to give the input, how to actually access it. All these things are present. So do look at it, do review these things, and you will learn a lot of stuff. There are various other prompts that is available based on the use cases, and based on the languages, based on the models. This is a different discussion altogether, right? The intention of showing you the prompt, showing you that the agent are just prompts, and in the backend you should be able to write appropriate. You need to write the prompts, and also you need to test them. So that is a series of videos where I discussed about DSPY, which helps you to write the prompts and test. That's one way of working on. And this discussion where I am introducing agents and how to work with agents in a step-by-step fashion. If you look at this, let's go back. So if you look at the output that you got in this case, just a second, let me scroll up. So here the agent is doing all the work. I mean, the Python object that got created in this case, the JSON agent, when I call this method run, that run is actually doing all the work for you, right? And it is not stopping if you ask to. So once you start this run, it will do all these things step by step, and then it will complete it, and it will say finish the chain, and it will come out. Even though this is an agent, actually in the backend is just a chain of large language models, prompts, and output parser. I'm repeating it so that you guys can clearly keep that in your mind. And this step-by-step process, and final checking that, okay, if the final answer is, if the final thought is I know the final answer, then so there will be a Python logic which looks at this result, and then it gives the final answer as output. So this is all done through Python logic. It's not done through LLM. And how it is being implemented, where is this being implemented, all these things is pretty complicated to explain in the short video. But I hope that this video provides you the curiosity to start disassembling the agents and the tools. In fact, I have you can actually go ahead and disassemble the tools also. So if you go up a bit, and if you look at the TavilyTool, sorry about that, if you scroll down, you can disassemble this tool also, and you can look at the various parts of the tools. So if you look at this tool in this way, if you try to print the tool, that itself will give you the lot of information about its name, about its details, etc. So if you put the name, it will provide the name. So it is providing the name. If you take that out, and if you ask for some more information, so like this, you can dive into the each and every part of the agent creation process, and you can review where and all the prompts are present. So in that way, what will happen is you will start understanding not just completing the tutorial. You will also understand how the parts of the tutorials work. So try to review the tools, how to work with tools and agents, how the tools are actually put into the agents, and how you can get a lot of better output by reviewing these agents, which are just prompts. Let's go back. So if you have any questions, do leave a query in the comments. I will try to respond as soon as possible. And if you have further doubts on a particular agent or a particular tool, and you want to review, do provide the background information on the code in the comment itself. I will try to provide some feedback. With that said, I would like to leave this video with 4 words: Disassemble tools, disassemble agents. See you guys. Have a great time.